Hi everyone, my name is Manny and I'm here for the Mega Fave Numbers project. I'll present to you one of my favorite numbers over 1 million. This isn't the kind of thing I usually do, but today, the actual math YouTubers made it look like just about anyone can join. So, here I am. Before we get to the number I actually chose, let's start with this one. This is a very interesting number in its own right. Maybe someone else will make a video about it. Some of you might recognize it, or at least have a guess as to what it is. This number is none other than 2 to the power of 32, where 32 is itself a power of 2. This number plays a key role in computing, in programming. If you have a 32-bit variable, this is the number of possible values it can take. If you have memory addresses that are 32 bits wide, you can't address more than this many bytes. If you were to mine some bitcoins, you have a nonce, which is a 32-bit value, so you can only go over this many hashes before you have to change something other than the nonce. If you take this number and multiply it by the current difficulty of the Bitcoin network, you get the total number of hashes calculated every 10 minutes. But this is not what I'm here to talk about. Let's see what happens when we take this number and add 1 to it. This number gave quite a bit of trouble to the mathematician Pierre de Fermat. He was actually a lawyer in his day job, but he did a lot of math. Today, Fermat is most famous for the so-called Fermat's last theorem. But regardless of that, he was also interested in numbers of the form 2 to the power of 2 to the power of n plus 1. The first number of this type is simply 3, which is a prime number. The next is 5, also prime. 17 is also prime. 257 is prime. It's not so obvious, but 65,537 is also a prime. At this point, Fermat thought maybe all numbers of this form are prime. But then we have this number. I talked about how a number similar to this one is important in computing. But back then, they didn't have computers. So when Fermat tried to verify whether this number is prime, he had some trouble doing so. In fact, he died still thinking that this number and all the numbers that follow are prime. Only in 1732, Euler came along and proved that this number is composite. It is not a prime number. It can be factored like this. Today, we have computers and we have better understanding of number theory. So we checked many of the next numbers in the sequence and all of them were composite. Maybe there is another prime down the line, but we couldn't find it. So when Fermat thought all those numbers are prime, he wasn't just wrong, he was very, very wrong. And the numbers which proved him wrong are these two numbers over here. Finding them was hard, but once we have them, it's very easy to multiply them and see that they are indeed factors of this one. In fact, we don't even need both numbers. If we only have one of them, it is very easy to divide and find the other. So really, either one of these was enough to prove Fermat wrong. The number 641 is less than 1 million, so by the rules of the contest it is disqualified. This makes the other number, 6,700,417, the winner by default.
Default! Woohoo! The two sweetest words in the English language! Default! Default! Default!
There is a lot more information about Fermat primes on Wikipedia, so make sure to check that out. This video was part of the Mega Fave Numbers project. If you have a favorite number over 1 million, make a video about it, include the hashtag MegaFaveNumbers, and do it by September 2. There are lots of cool videos in this project. Make sure you watch the video by 3 Blue 1 Brown, which, much like the Hunchback of Notre Dame, is a tale of a man and a monster. Thank you. Enjoy the rest of your day.